Okay, my children of the corn. In this video, I'm going to show you how to find the area of a triangle given two sides and the angle in between, and then given two angles and a side, either AAS or ASA. We're going to start though with the first case, the SAS case, where I give you two sides and the angle in between. The formula for this case is 1/2 AB sine C. So the first thing I want to do is just write this a little bit differently on the screen so you could see. It's 1/2 AB sine C, and I'm just going to separate that a little bit. So let's say that I give you sides A, B, and angle C. So if I have side A, that means I have little a, and if I have side B, that means I have little b, and let's say I have angle C, which is the angle in between. I'll mark that with a tick mark. Okay, so this represents two sides and the angle in between. And I want to show you that this is the formula, and I'm going to hopefully prove to you why it is. So I'm going to start with what I know from geometry, and that is area of a triangle is 1/2 base times height. Okay, well in this particular setup, the base of the triangle is side A. And luckily, I know what that is because it's given to me. Now, what I don't have is the height. Remember from geometry that height and altitude are the same thing, and altitudes are perpendicular to the base, and the height has to be perpendicular to the base. Well, this particular diagram, there's no such height there. So what I need to do is drop an altitude from side A so that I get this height or this altitude. So I'm going to go ahead and do that now. Now remember that when you drop an altitude, you get a right angle. And if we look at this triangle off to the side, off to the left, I'll call it Roman numeral 1, so you know where I'm looking. We can use basic right triangle trigonometry and the sine ratio to figure out what this height is. Now I'm going to go ahead and call this altitude h for height. And then I'm going to say off to the side that the sine of angle C is equal to the opposite over the hypotenuse. Now opposite of C is h, and the hypotenuse is little b. When I cross multiply, I get h equals little b sine C. Now the second part of the formula that I'm trying to derive requires that I write down the height. Well, we just figured out the height over here to be little b sine C. In words, to find the area of the triangle given SAS, or two sides and the angle in between, you're going to multiply 1/2 times the product of the two given sides times the sine of the angle in between. In this second part of the video, I'm going to show you how to find the area of a triangle given two angles and a side. And this can be delivered to you in either an angle-angle side situation or two angles and the side in between. So either way, it's two angles and a side, it's just the arrangement, and it really doesn't matter how it's given to you. And the formula is a little bit cumbersome. It's 0.5 or 1/2 times the given side squared times sine of angle 1 times sine of angle 2 all over the sine of the opposite angle. Now, let me just clarify by saying angle 1 and angle 2 are going to be the two angles that include the given side. So these two angles here include the given side. And down below in the denominator, when I say opposite, I'm referring to the angle that's opposite the given side. Okay, so let's say hypothetically in this problem, I give you two angles and the side in between. So let's say I give you this angle here, and I give you this angle here, and the side in between would be little b. So let's start with what we did in the first derivation, which is area equals 1/2 the product of the two sides times the sine of the angle in between. So remember, I know what little b is, so this is good. I know what big C is because that's given, so that's good. The one thing I don't have is A. This is what I need to work on right here, and I have to somehow make this formula look like this big thing over here. Okay, now, if I know angle A and I know angle C, then I can subtract from 180 and very easily get angle B. So I'm going to mark that as though I know it, because it's so easy to find I practically do know it. So I'm going to put a tick mark there indicating that I know it. Now, assuming that I know what B is, or that I can find it very easily, I see that I have an angle-side pair, which allows me to use the law of sines. So off to the side, I'm going to set up a law of sines. Sine of big B is to its opposite side of little b. Now keep in mind I'm looking for A. In fact, I want some sort of expression that has a little a in it. So I'm going to involve big A, little a. So this setup right here comes from the law of sines. Cross multiplying and isolating little a, I get little a is equal to little b sine A divided by sine big B. So I'm going to take this expression for A and I'm going to substitute it in here, and I'm almost going to be done with the whole derivation. So what I've just done is rewrite all the parts that I already knew or that I had, and the only thing I've left open here is what A was, and I just figured out what A was right here by doing this down here. So I'm going to put in B, little b sine big A, divided by sine big B. Now my objective is to make this look like the formula that's initially given to me. So another way to say 1/2, of course, is 0.5. Now remember, side B was the one side that was given in the beginning, and that happens here and it happens here. So I really have B times B, which is your given side twice or squared. Now sine of A and sine of C. A and C are the two angles that were initially including that given side. So in the formula we generalize that by saying sine of angle 1 and sine of angle 2. And then angle B is the angle that's opposite the given side of little b. So we write sine of opposite. And this right here is the formula you're going to use if you're given two sides and the angle in between. And that might be presented in two different ways, either as an AAS or ASA case.